Hey there, this is Sid and today we shall try to solve a SQL problem from StrataScratch. The title of the problem is hour with highest order volume. As always, we shall start off by having a look at the input table. For convenience, I have exported the input table onto Microsoft Excel. So this is the input table, and for the purposes of this problem, we would be interested in the columns ID and the timestamp. So the ID is the unique identifier of some orders that are placed, and the timestamp is the timestamp when the order was placed. There are a couple of other columns like customer ID, courier ID, seller ID, amount, and city ID. The meanings are obvious, but for this problem, we really don't need those columns. All we need are the ID and the timestamp column. Now let's get back to the problem and try to understand. It says which hour has the highest average order volume per day. The sales can happen over multiple days, right? So for example, here you see some of the sales happened on 11th of March and some of them happened on 11th of April. And they also have a distinct timestamp. So these last 5 bits or so, 23:27, 4:24. So these are the times when the sales happened. So basically it asks us what's the busiest hour of the day in terms of volume. So there are 24 hours in a day. You can split that into 24 chunks from midnight to 1 a.m., 1 a.m. to 2 a.m., 2 a.m. to 3 a.m., and so on. And within a given 1 hour window, sales will happen, and it will happen over multiple days. So you have to calculate the average hourly sale averaged over all the days. So that's the ask of the problem. Which hour was the busiest in terms of volume of sales? Mind you, that's not in terms of the amount. It's just in terms of the count, that is the number of sales that happened. So I hope we understand the problem now. So here's an intermediate table where I have kept the ID column from the input table, and I have created a new column called date. So this date column is generated by extracting the date from the timestamp, and similarly the hour column is generated by extracting the hour from the timestamp. So you see the first order came on 11th of March at 23 hours, that's 11 p.m. The second order came off 11th of April at 4 hours, that is 4 a.m., and so on. Now as we said, what we have to do is we have to find out the average hourly count of orders. For that we have created a pivot table here. It has columns for all the unique dates on which the sales happened. Since we have only two dates here, 11th of March and 11th of April, there are only two date columns. If we had 10 instead of 2, we would have 10 date columns. And this column N, has the hour tags. So 0 means midnight to 1 a.m., 1 means 1 a.m. to 2 a.m., 2 means 2 a.m. to 3 a.m., and so on. On the whole, what this table does is it tells us on a given hour slot, say this slot, how many sales happened on 11th of March and how many sales happened on 11th of April. Again, this is just the count of sales, nothing more than that. And the column Q gives us the total count of sales that happened within that hour slot for all the days. So this 2 is just the sum of these two. Similarly, this 2 is just the sum of these two. This 1 is just the sum of these two, but there were no sales made on 11th of April in the time slot 2 a.m. to 3 a.m. So we have only 1 here. I hope we understand how this column Q is generated. So this is the table which almost solves the problem for us. All we have to do is generate the average hourly volume in terms of counts of sales. So how do we arrive at this number? This number is nothing but what was the total number of sales, that is 2, that goes in the numerator, and in the denominator we need the count of the distinct dates on which the sales were made. So here one sale was made on 11th of March, another was made on 11th of April. So the sales happened over 2 days. So this is 2 by 2, hence it is 1. Similarly, here the same thing. Here the total number of sales is 1 and it happened on 11th of March. So the ratio is 1 by 1. This one, the sales happened only on 1 day, but 2 sales were made. So the numerator would be 2 since the total number of sales made were 2, but the denominator would be 1 because the sale happened only on 1 day. There was no contribution to the sales from 11th of April. So 2 divided by 1. So the denominator is basically the count of these two sales. If there is value in one cell but not the other, the count would be 1. If there is a value in both, the count would be 2. So in this way we have arrived at this column. Now since they want us to output the highest hourly volume, we can simply eyeball this table and say that the highest hourly volumes happened between 3 a.m. and 4 a.m., which is this row, and between 8 a.m. and 9 a.m., which is this row. So our final output would be, in the time window 3, hourly volume was 2, and in the time window 8, the hourly volume was 2 as well. And that is what they have given us here as well. If you see, hour and average orders count 3, 2, and 8, 2. Now let us try to implement this logic in SQL. As always, I have written the code in Notepad++ because it's much easier to follow on Notepad++. Our first city is daytime orders. It's very simple. It selects the ID, then it extracts the date from the timestamp and the hour from the timestamp. That's all it does. So this city is exactly analogous to this table that we have here. The next city is average order volume. What that does is, for each hour, it counts the number of distinct IDs. Each ID corresponds to one order. So it counts the number of orders, and it also divides it out by the number of distinct days on which those orders were processed. So the numerator count of IDs corresponds to the total sales made. And the denominator, the count of distinct dates, would be simply the count of distinct dates over which those orders were processed. So these two came over two distinct dates. These two came over only one distinct date. These four came over two distinct dates. This one came over only one distinct date. So that's our denominator, and the ratio is called the average orders count. So once we have written the code up to this point, let us see what the output looks like. If we say select star from the second city, what it would look like is this. For each hour, it gives the average orders count. You see here, for the hour 3, the average orders count is 2, and then again for hour 8, the average orders count is 2. For the others, it's 1. So going back to SQL, this final select statement outputs everything from the second city, but applies a where condition or a filter condition. It says the average orders must be the maximum of the average orders. Since the maximum is 2, it is basically saying select everything from this city where the average orders count is 2. So now that we understand the SQL query in its entirety, let's try to run it in the SQL editor of StrataScratch. As you can see, our output is hour 3, 2 orders per count on average. Hour 8, it's 2 orders per count on average, which agrees with the output provided by StrataScratch. I hope I was able to explain the solution to this SQL problem. I'll keep coming back with solutions to more SQL problems from StrataScratch, so please stay tuned.